Hello and thanks for joining me. Well, I'm going to do a thread cutting video, another thread cutting video. There's a lot of them out there on the internet. Maybe I can add some new perspective on it. What I'm going to be doing is manual threading. It's called single point threading. There's several different methods to do single point threading. You can do it in reverse, do it with the tool upside down. I can't do it in reverse on this lathe because I got a screw-on chuck, and there's a chance the chuck will unscrew. The only advantage to doing it in reverse is you're threading away from the chuck. With right-hand threads on this lathe, in the forward rotation, you're threading toward the chuck, which in some cases is a little inconvenient. I'm also going to cover how to use these right here. They're called Pee Dee wires. It's how you measure the thread depth. Most of the time, I just try a nut on it. If the nut fits, the threads are good. But in some situations, you want more accuracy than that. So, anyway, let's get on with it. First thing we need to do is discuss appropriate threading tools. Here's a high-speed steel one. Would probably work perfect. I like carbide. They stay sharp pretty good. Profile is always perfect. This one here will cut up to half 13, I believe, although that's kind of pushing it. Here's one probably more appropriate for this size thread. Here's one for internal. That's for going inside a hole, but we won't use that one today. This is what we're going to use today. We're going to cut some half 13 threads. Okay, I should probably discuss this little tool here. It's got all kinds of writing on it. I don't know what all of it means. I'd say most people don't. But what it's for is squaring up your tool post or the tip of your threading tool to your work. I'm not talking about compound angle. You've already got your compound set at 29.5, and then you use this. You loosen your tool post and turn your tool so it's square or matches that groove exactly. I'm going to cut threads on this end, and you'll notice I beveled the end. It takes more of a bevel than you might think. This is one I did a minute ago. Notice this undercut right here. It's the small diameter in those threads. Is how far you got to take that down. That's a place the threading tool can go to and then pull out. It's a place to stop your threads. Okay, I'm going to thread this end. First thing we got to do though is cut that relief. Have it as close as possible to your chuck. You don't want to run into it. If you have it sticking out any further, you need to put a support on the end. Okay, let's look at the thread formation here. This is a unified thread, which is, you'll see it quite often, UTC or UTF. That's unified thread coarse, unified thread fine. It's the US standard, English, whatever, non-metric thread. Anyway, the pitch is like from top to peak to peak. They call it crest. We're going to cut a 13 thread per inch, so that's what the pitch is, 13. The flank is part way down the slope. We'll get into that more later. Right now we're looking at the root diameter, and the root diameter is the bottom of the threads. But you'll notice on here, the threading tool actually goes down like this. So, we really need to make that undercut right there. Well, there's charts that show that root diameter, but they don't do much good because you got to take off a little bit more than that to get to the bottom. So what I usually do is we're going to make half 13 threads, so I look at my thread chart for tap, and it takes a drill 0.422. And what you do is you subtract 10%. So there's 0.422 minus 10%. And it gives us a diameter of 0.379. Well, that's pretty close to what it needs to be. Let's see what I did this undercut. 0.386. Not too far off. But that's a really good way to determine the undercut. I'm touching right there. Re-zero my cross slide. Take 55 thousandths off. I'm going to use a little, make it twice the width of this cutoff tool. It'll be about a 1/4 inch wide. Cutoff and grooving tool. Let's discuss the compound angle. Threads are cut at a 60-degree angle, meaning 60 degrees from there to there. So half of that is 30. Well, the recommended setting for a compound is 29.5, which is really close to 30. But the reason they do that is because with each cut, now this is the carriage direction. Each color here is a new cut. There's cut 1, and you'll notice what's going on right here. The second cut I make goes in that way and this way. Okay, same with this one. It's going in that way and this way. Now you're only moving your compound in this direction, but in relation to the work, you're cutting a little bit on this side and most of the stock on this side. And the reason they do that is to give you a good smooth thread right here. If say it was, say you had your compound errored like 30.5, what you would end up with is a stair step right there, because it would slowly be moving away from the previous cut. Here's a better description of what's happening, I think. Okay, this is our carriage travel. Compound set at 29.5, and this was my first cut, the brown, and the green is my second cut. Now over here, this is where the carriage is already cut. Now I've overlaid the previous cut, and you'll notice right here there's a little gap. That's because this cut took out 1% on this side and 99% on this side. So every cut takes most of it off the left side and just a little bit off the right side, like that. That's why you set the compound at 29.5. Okay, here's the tool we're using. This is what I like to do here. This is just a machinist rule. Stick it between the tip of that threading tool and make sure that's vertical. Looks pretty close. Could bring it up just a hair. Looks straight. I'm calling that straight. Okay, let's discuss the threading dial. This is the threading dial right here. It's driven by the lead screw, and the lead screw moves your carriage. When the carriage is moving, the dial is stationary. But when it's not moving, here I'll turn it on and I'll show you. When the carriage is stationary, the threading dial is moving. And what that's used for is to tell you where to engage the half nut. The half nut is what engages the carriage to the lead screw, and then the carriage will start moving. Okay? So, if I'm cutting thread, I've got to throw it in a certain location. Well, because we're cutting on even threads, we're going to cut odd threads. We're going to cut 13 threads per inch. But on even threads, I can throw it in on any mark. But because I'm cutting odd threads, you got to throw it in on two opposing marks. Now this particular dial has a 1 and a 2 on it, and then just two marks that are not numbered. I can either throw them in on that mark, or I can throw it in on the 1 or the 2. But whatever I do the first time, I have to continue doing that. So if I throw it in right there, then I got to throw it in on that mark or that mark every time. And cutting threads is a multi-pass operation. So, well, I'll get into that more later. But this is a half nut. It engages the carriage to the lead screw, and this thread dial throws you where to engage the half nut. Okay, this is my quick change gearbox. Some lathes do not have a quick change gearbox, and you have to go in under this cover and change gears over here to change the speeds. Quick change gearbox is really nice. It's very convenient. It looks complicated. It's pretty simple. I'm not going to go into a lot of detail on it because every one of them looks a little bit different. But basically, it's got two levers, and these levers can move and engage in different locations. Sometimes you got to move the chuck to get that to engage. There we go. Anyway, right now it's set up for 13 threads per inch, and you find the 13 on there. There it is right there, and that's where you line up this lever. And then you go across here, and it says A. That's where I got it engaged. There is some fairly extreme thread sizes where I do have to change a gear over here. See, they're all the 24 tooth. There's a 48 and a 48. But that's something I'll never do. That's 4 threads per inch, 5, up to 7 threads per inch, and then it goes to 8 threads per inch, and you don't have to change a gear. They all use the same gear. Anyway, it's set up for 13 threads per inch, so we're ready to cut threads. Okay, this camera angle is going to be kind of tricky. Hard to get to my controls with the camera there. So what you want to do is run the tool into the work. Okay, I'm touching right there. Then I'm going to re-zero my cross slide. Now it's on 0. Bring the tool back out to the end, set my cross slide back on 0, and go in about 10 thousandths right there. Now I'm ready to start. My thread dial, I don't know if you can see it over here or not. I think there's glare on it. But I'm waiting for a number to come around. Okay, there's a 2. I'm going to engage it on the 2. Now I'm going to cut my first pass on the threads. Just barely touching. Disengage the half nut. Back the compound back out. Go back to the beginning again, to the end of the shaft. Go back to 0. Another 10 thousandths. Wait for a number to come around. Engage the half nut. Taking a little more of that pass. Disengage the half nut. Back out the compound, or not the cross slide. Back to 0 on the cross slide. Add 10 more thousandths on the compound. Wait for a number to come around. Engage the half nut. taking even more there. The deeper you go, the more metal it's taking. Disengage, back out to the end of the shaft, back to 0 on the cross slide. Now I've got to start reducing how much I take off. I'm going to take 5/1000 on this pass. And the reason for that is you're taking a lot more metal as you go deeper, and add a little oil too. Wait for the number to come around. Engage the half nut. Disengage. Back out the cross slide. Back to 0. Take another 5 on the compound. Waiting for a number. Engage. Cross slide, back to 0. You just keep doing that, and I'm going to take 5/1000 on this pass, but after that I'll probably have to drop it down to 2,000. I'm going to focus more on the threads now so you can see what's going on up there. You see why that little undercut right there is necessary, and having a little extra width on it is a good thing. Just gives you time to disengage and get your tool out of there. I'll take one more. Okay, it's a little bit tight. What we got there, you'll remember on that chart. Let me show you the chart again. Notice that the tip of the thread is knocked off. That's how it's supposed to be. So they make special files for this too. I don't have one. But just knocking the tips off those threads will probably make that nut. Oh yeah. That's a perfect fit. Now that's one way to check the thread for the proper depth, but there's a more scientific way too, and we'll cover that here in a minute. Okay, this is what we're going to use to measure our threads. They're called Pee Dee wires. I don't know where they came up with that name. There's 3 wires for each diameter, and there's a chart that came with it. But here's a duplicate of the chart in a larger size. Okay, you got wire size and threads per inch. And what do I got there? 45 thousandths wire. So in this set, I pull out the 45 thousandths wires. Then, it's 3 of them in each diameter. You lay them in the threads like this. It helps to have 3 hands. Just like that. Then you put your micrometer on top of the wires. And you have to let the wires go because it has to, they have to rotate and conform to the threads. That's why I got the rag there in case I drop them. Okay, that's it. Can you see that real good? So I've got that measurement right there. Maybe a little tight. So it says 521. I'll write that down somewhere. 521. Okay, on this chart, right next to the 45 thousandths wire is, they call it a constant, 0.06838. You're supposed to subtract that from the number I just got, the 5.4526. 0.4526. Okay, sorry for everything being upside down. I came up with 0.4526. Okay, on this chart here it shows the pitch diameter, 0.45. So 0.4526, and I'm supposed to be 0.45. That's extremely close. Very, very slightly oversized. Well, that pretty much wraps it up for today. Another threading video. Yeah, those threads are just a hair tight. Good working threads though. Well, thanks for joining me and be sure and subscribe.